Very good afternoon, one and all present here. I am Falguni Kenjgundi from LM College of Pharmacy. Am I audible?
Yes, Falguni, you are audible. Go ahead.
Thank you, ma'am. I am very grateful for this opportunity to welcome you all on the occasion of National Pollution Control Day webinar and the topic on recent advances in environmental technologies for achieving vision of Swachh Bharat. As we are aware that LM College of Pharmacy is persistently taking initiative to create awareness among young minds about pharmacy profession. I heartily welcome respected Principal Sir Dr. M.T. Chabaria, Speaker of our today's session Ajay Gajjar Sir, all faculty members and my fellow colleagues. With great pleasure, I would like to invite Dr. Mahesh Chabaria Sir, Principal of LM College of Pharmacy, to brief us about the event and enlighten us with his kind words. Welcome you, sir.
Thank you, Falguni. Sri Ajay Bhai Gajjar, the expert speaker of today's expert talk. Dear faculty members, students, on behalf of Institutional Innovation Council of LM College of Pharmacy, Atal Incubation Center, AIC LMCP Foundation, and on behalf of LM College of Pharmacy, I heartily welcome Shri Ajay Bhai, all faculty members, and all participants. Our institute's IIC, that Institutional Innovation Council, regularly organize such kind of webinars which helps or motivate the participants who wish to do the innovation or invention in the field of their interest. Now, what are the innovation or invention we do, or our country does? Nowadays, the environment always remains in the center. Environment protection in any kind of innovation and invention is always at the forefront. So, as a participant, we all should know about how we can protect the environment and how we can make our Bharat, our dream of Bharat, the Swachh Bharat. So today's expert surely enlightened us about the environment protection and preservation in his expert talk. I welcome you, sir, once again, and thank you very much.
Thank you.
Thank you,
shall I
sir.
start?
Now I would like to introduce our today's speaker, Ajay Gajjar sir. He is a competent professional having academic engineering background with more than 20 years of qualitative experience in project sales, marketing and environmental projects, which helps our Indian mission of Swachh Bharat. Currently, he is working as a general manager sales and proposals in SFC Environmental Technologies Private Limited. SFC is global water and wastewater company. It has its headquarters in Navi Mumbai, India. With group companies of the world, the company provides cyclic activated sludge technology known as CTEC for treating domestic sewage and industrial effluents to the highest possible quality at a very low cost of treatment and by using space and power. There are numerous plants advances technologies in the field of municipal sewage like turboflower and fiber disc filter from South Korea. Company also provides design engineering services for complete STPS procurement and project management services. I again welcome you, sir. Now hand this session on delivering on the topic on recent advances in environmental technologies for achieving vision of Swachh Bharat. Welcome you, sir.
Yeah, thank you, sir. First of all, can you hear my voice, no? Hello.
Yeah, it's fine. Yeah,
Yes,
it's
sir.
fine.
Yeah. So first of all, I am welcome so Honorable Principal Sri Mahesh Chabaria sir for giving me an opportunity to present few of our achievements, significant achievements which we have done in the mission of the Swachh Bharat. I would like, and I am very grateful for providing such a platform for Dr. Praful Bharadia sir. And again, I am thank you to Honorable Principal Sri Mahesh Chabaria sir. So I hope this is not a typical type of presentations, just not academic, first of all, because many kind of the presentations, they are just on the books. But we brought this kind of the innovative concepts in a big way in a municipal segments and for the sewage treatment plants, like for providing the technology. So many of us just think about that. What about the Swachh Bharat? Swachh Bharat we can make on the various way, like cleaning, and first of all, Swachh means it just appealing us for the cleaning. So how we clean it. So we are in the field of to clean our river, because river is a heart of any countries, because the river, very clean river is our life. So definitely, and today's lot of government is spending huge money to keep Ganga cleans and a lot of rivers everywhere, here in Sabarmati cleanings and everywhere. Because earlier there were no threats like this, but nowadays when urbanizations develop, you can see that all the sewage. For example, if everybody aware about Damdabad, we just heard that Pirana and some Vasna areas are just outskirt area. So all the plants earlier, they were the outside of the town or few kilometers away. But nowadays, urbanization grows very fast. So we have, but even government have a very good challenge over that. We have to set up something like that treatment. So plant should be eco-friendly, nuisance-less, odorless, and anybody can visit. Very enthusiasms. So we have started to bring this concept. So let's we start. So SFC Environmental Technologies basically is the world largest sewage treatment technology company, and basically this is Austrian company, and we have started this operation in India 2005. SFC this India acquired, we have taken the major stakes in SFC Austria in 2009. So it's a, we can say it's an Indian multinationals. So what is the CTEC? CTEC is a trade name. And what means the SBR? SBR means sequential bioreactor.
Sir,
So
your screen is not
CTEC,
visible.
is it?
Yeah.
One.
You can share your screen, your presentation.
But
Yeah.
everybody here my voice? Praful bhai?
Your voice is available. Presentation is not seen, so you can share it again.
Yeah. Now it's okay?
Yes. Okay.
Now you can see, na?
Yes. That's fine.
So let's be fast at SFC is the world largest sewage treatment technology company. This is basically the Austrian company. In India, we have started in 2005. And at 2009, we have taken the major stakes in the SFC groups. So we can say it's an Indian multinational. So what's a CTEC? CTEC is just a trade name. So before to understand this slide, let's we just these slides. Okay. So basically our technology is used in the sewage treatment plant for treating the biological treatment. Earlier, what happened? All the raw sewage comes and some primary treatment. They are removing some screens and this unorganic, this is floating material, then grit removal, and then comes into primary clarifier, secondary, and you see the number of units over there. So all these are not a fully environment the lot of units, and instead of that only 2 units or 4 units or 6 units over there. So these are the concepts. So it's a compact plants, not only the compact but odor free, eco friendly, and even when we can arrange some conference meeting over there. Okay, so this is called as a sequential batch reactor technology. So what is the CTEC do? CTEC is the most advanced and cost-effective sewage treatment technology in the world. Is a aerobic biological process to treat the sewage to a recycled quality in a single step. As I told, this is a biological process. Our STP can also produce the gas electricity, recyclability water, and manure through the outputs. And STP can generate the revenue from the sale of the above products. Now, see, earlier what happened, we just not concentrated more on the sewage treatment facilities and like that, but we have just changed the total concepts. So we have given to society that sewage treatment plant is nothing, but also you can give from cost to profit. Not only just save our river and this, but you can also produce something good, recyclable quality of the water, so you can use on the non-potable use. So we can generate the biogas also. So we can also the treated water, that is this kind of the quality BOD, TSS, and as per the NGT rules. And we can use in the recycle for the non-potable use. And by this way, we can save the plenty quantum of the drinking water. Here in the green slide, we can see that earlier, what's the norms? Is a 2030. 2030 means the BOD, biological oxygen demand, earlier asked only this is a 20, and total suspended solid is a 20. There is no provision of nutrient removal, nitrogen and phosphorus. So what happened? I think all of us, we have noticed in some river and some ponds that some algae formation over there. Why this algae formation over there? Because of the treated water, there is no nutrifications and no kind of the treatment over there. So nitrogen and phosphorus, all contents go in the river, and they lot of imported machineries and manpowers and money power to just remove that algae. So later on this stage, government have identified that why this happened. So most of that sewage treatment, treated water, they first all the treated water comes to the river, pond or whatever the reservoir here there, directly or indirectly. So we have to just we have to just find out the solution from the grassroots. So they have prepared the norms. They have changed the norms drastically. They have to change the norms. Earlier there is a BOD, for example. BOD is a 30, TSS is a 30 or 50. So later on this, they have this CPHO manual. They have established that the BOD should be the less than 10, TSS should be also less than 10, nitrogen and phosphorus removal. Okay, but in the CTEC, at the beginning stage, we are giving this thing at the single step. There is no one plant in India. At that time, the same quality we are producing. So for us, it's not a new. For us, it's our nature of this, beauty of this technology. You can see that nowadays, all technology, if we count total MLD, we can say the 18,500 MLDs. And by the CTEC, our SBI technology, we just reached 14,000 in 2021. It is much more, even this 22. Why this thing? Because looking to the norms, treated water norms, this technology is very robust and lesser O&M. Is produce recyclable water at the very low operating cost. That's why the large acceptance we can get from the government organizations. We can see here is a produce recycle quality of treated sewage. BOD is 5, COD is a 50, TSS is 10, nitrogens 1, and total phosphorus less than 1. You can see this in 2003 CPHO and National Green Tribunal 2019. They recommended BOD 10, even we are giving, even though less. COD 50, TSS 10, total nitrogen phosphorus removal over there. So neutral removal parameters they have added in the manual. So every STP must have to fulfill this criteria. Can see the clean river as before the earlier. As I have explained this thing, what the conventional plants. Hello. You can listen, na?
Yes, sir.
Okay. So earlier this is a conventional plant. So they are removing the impurity. If we just speak in the layman language, because a lot of our colleagues, they don't know into some biological process. But we can say earlier what happened, we are removing all the impurities by stage. 30%, then 30% like this way. It occupied a lot of space. And if you install a lot of machinery, so obviously there is a O&M will be much more over there. So we just change the concepts. All this process, it comes in the single basins. In the 3 cycles, we can say First the raw sewage comes, then he just filling and aeration 1 hour. 1 hour is a settling period and 1 hour is a decanting. Decanting means we are removing the top supernatant water from the by our decanter devices. So all this process controlled by our PLC SCADA. So good monitoring system over there, no human touch over there. So irrespective of design parameter of inlet parameter given, we can get very good quality recyclable quality water. Here we can see how the raw sewage, and we treat like this. BOD, you can see that is less than 5, COD 50, total suspended solid is a 10, and nitrogen and phosphorus removal over here. Other remarkable also, because we have reduced the land requirements. See, in the government project, the acquiring the land is a huge task and very critical task. Even mutual government, even the government department internally, they cannot hire because of so many legal procedure over here. So earlier that pond and all this culture now gone. Now there is a lot of societies and residential plots are available just adjoining over the STPs. So land is a very important. So you can see here that earlier there is a just this example I am giving you. 100 MLD STP based on the conventional process, they occupied 6.13 hectare, and we just set up this same MLD in 2.2 hectare at Navi Mumbai with good aesthetic value also and good quality of the water, and even the lower O&M cost. That is a huge impact in the government departments. So they have to acquire very less space. Other thing is that, see what happened in just this kind of the infrastructure projects. All the sewage treatment plants, the works comes under 5 years O&M, 10 years O&M, 15 years O&M. So some kind of the bid modalities that all electricity power you have to bear by the contractor or otherwise by the government. So after this technology available, and we form the norms that everybody, every technology, there are other comparatively other conventional technology also, they have to compare. Suppose I am giving the very less cost of the treatment cost, but treatment I am capital cost is my less, but my O&M cost is very high due to the power consumption. So we have inserted so many evaluation points based on the land, based on the power. So government can get a good quality of the technology, will consume the less power, less lands. So there are loadings over there. So mostly 50% power we consume the less. Even though we can also generate the gas generation also, we can, because if my inlet BOD is more than 300 consistently, so we can also utilize into the power also by the generated through gas. As I told you earlier that we have introduced this life cycle cost principle in the sewage treatment plant. Earlier there was nothing over there. Nowadays every concern now the government is calculating. Now we have offered the lowest life cycle cost by saving land cost, maintenance cost, operating cost, and simultaneously generating the valuable product in form of the recyclable quality of the treated sewage, biogas, and the manure is fully digested. We can use directly use in all our crops because it's fully digested. You see that all the plants control the PLC SCADA system. See, there is many points, because earlier what happened, see what we are doing in the sewage, particularly this biological process, is just game of air. See, the manual is deciding, suppose if I have to remove some BOD, certain I have to put mechanically or by naturally to that water. So per kg BOD removal, I need to supply some quantum of the air. There is a fix. What we have done, that controlling by my computer, okay, how much air I require. So that's why I save the lowest power, because of this SCADA systems, this oxygen uptake rate that we have given in our technology and our software. So only see, this is a biological treatment is just a live, is we can see is a live bacteria. Suppose हम किसी को ज्यादा खाना देंगे तो भी वो मर जाएगा, अगर हम किसी को कम देगा तो भी प्रॉब्लम क्रिएट करेगा. So neither less, neither up. So we have to just feed designed rate of the air to the inlet raw sewage. So who decide? Though that's the deometer through my SCADA system will decide. So there is no human interference over there. That's why we are getting excellent water quality irrespective of the variation in the raw sewage quality, because our SCADA system is there. You see that we have changed the concept that see, STP is nothing. As I think many of us visited abroad, and we must see in the facilities, the commercial building like this way. So we bring this concept over here. So you can see that this is my 100 MLD plant building over there. So you can see it looks like some corporate office, and inlet very facilities are there, hygienes, and aesthetically value we have added. It's a very changeable and remarkable. This is a remarkable things in India. Just we change the concept. The treated sewage is not just you can throw it out. It's a source of water. So additional source of water for non-drinking application, that is industrial, construction, bulk washing, horticulture, agriculture, etc. in the non-potable use in India. We have a setup in Malaysia. There is our largest plant. It's more than 400 MLD over there. So the Malaysia, they are biologically treated water and supplied to Singapore through the pipeline. And the Singapore, they have a tertiary treatment through RO, and that water they are using for the drinking purpose. In India, at present, no need like this. Even if we just fill the gap of non-potable water by this kind of the recycled water, then it's a big deal for the India. So even government, they are also the sensible. Current government, since last 10 days, infrastructure projects are developing under Nitin Gadkari sir and many other ministers. They are very dynamic, and they have taken a very initiative because of this large this type kind of the format. Unless and until the supports from the politicals and all this movement, we cannot get the success. It's not only the technology. We are available, but something so we are also simultaneously the same, the grateful to that also, people also. And same thing, the awareness also. Nowadays, people are also aware. Hello. Can you hear my voice now?
Yes, sir, you are audible.
Okay. So the saved potable water can be supplied the water scarce regions of the state. If we can non-potable use, we can fill the gap. So remaining drinking water we can supply to the states. So we just converted STP in the revenue centers, and that revenue gets generated from the sale of the treated sewage. We can also see that this is not just talking. Now in actions also we will see. See here, first 130 MLD treated sewage for Mahajanko thermal power plant in the Nagpur. So what happened earlier, all these power stations, all these thermal power stations, they are required the huge quantum of the water, huge quantum of the water. They are purchasing from the irrigation department from Rs 25 to 40 rupees per kiloliter. So what we have done, we have set up 130 MLD treated sewage plant, the Mahajanko. Mahajanko is like Maharashtra's state government for the electricity generation, just like our GEB. So this plant, this water, treated water, we are giving to the Mahajanko, that is electricity board. And they are treating small, just adding them small treatment, and they are using in their for the power station. So by this way, we are just saving that 130 million liter per day water from the irrigation. So irrigation department can give same to the same way. We also set up in the Nagpur for 200 MLD sewage treatment plant for the same concepts. Here in 25 MLD, my Kharghar, Navi Mumbai plant also, they are using for the ponds and gardenings. 30 MLD water from 120 MLD to Gurgaon, Haryana, also being the recycled for the horticulture purpose. And in Noida, Uttar Pradesh, these are the few facts. Many departments now have started to recycle it, and they are earning also the money also for that. In Modi Saab is one vision, that is a zero discharge. So he just take initiative that why the gardens are using this treated water. And after then he gone to Central. That time the Anandiben Patel madam was there. 10 MLD our sewage treatment plants we have set up at the Sargassans. You can see the slides. And you can see that this overhead tank. This overhead tank is nothing but is a treated sewage water. By the gravity, they are providing this water to the gardening of the Gandhinagars. This is a small kind of the initiative they have taken. So again, we have concentrated more how we can further improve our this thing, because we have just saved the power through our technology. We have also using some innovative ideas, because again there's the blowers. How we can use some techno. So our work is still continue, and still we are improving, but a lot of innovations we have incorporated. So adapting this treatment process to vary is improvement. We have improved our decanting procedure. Decanting means that the removal of the water from the tanks is connected with our PLC SCADA. We are high efficiency and long life diffusers. Diffusers is just they are installed in the bottom of the tank. They are providing the air. So we brought this technology from USA, from ADI, and we also improved the material also for the, you can say the poly. Again, our concern is noise-free operation of the STPs. So we also introduced see this turbo blower from our Korean association company. This turbo blower is just like a washing machine. No need to install this type of typical kind of the foundation and is all. There is a air bearing. There is a drain, but nowadays it's a common, because we brought this concept in sewage treatment plants because we also have to reduce the noise of the blowers. So see, because most of all STPs, they are in the middle of the local community, so they should not disturb. So that's why we introduced this turbo blower. So in the Gujarat, in the huge plants, they are now they are using this thing. Just opposite Gandhi Ashram, we have established the 60 MLD sewage treatment plant in Ahmedabad Municipal Corporation in the silent zone. They have adopted over these turbo blowers, no noise over there. Again, the liquid waste, treated water, the simultaneously many of us just think about that, what you are doing about the sludge. that you are removing. See, we are removing the sludge on the 20% consistency. Still, we have to remove more consistency and make it more dry. So we introduce also the solar sludge drying system from our German associate group. And that dried sludge have a calorific value about 3000 kilocalorie per kg. So absolutely, it's good for cement industries and all. They are using their furnaces. Once again, if we treating our SBR technology, now a day, we have just expand in the huge way and number of plants in India. Now they are further, the department is also thinking about the further treatment. They are using the sand filter beds and like they require the huge space and different kind of the system, and O&M cost is also more. Here we can see this is a fiber dish system. This water comes through my SBR treated water and further treated, and it comes to the, we bring down the total suspended solid less than 10, less than 5. Here the installation, you can see that here is the fiber dish. This online is the cleaning, is a totally operated by the SCADA on the level basis. And total suspended TSS reading meter over also that sensor over there. So if more TSS, automatically gate will not enter the water in this chamber. So this picture you can see is the recently inaugurated by our Honorable Chief Minister, Sri Bhupendra Bhai, in the Sayaji Garden, Vadodara Municipal Corporation, because they are using this kind of the, you can see here, the quality of the water. So they are using this water in the gardening and to the Vishwamitra, because Vishwamitra riverfront program will be declared soon. So first they have all tap all these things and they improve the water quality. You can see the, so CTEC can contribute to state in the many ways, providing the efficient and reliable treatment of the sewage waters, reducing the water pollutions and improving the public health, saving our water bodies by completely eliminating flow of the untreated sewage, establish water security in the state by converting sewage into recyclable water, quality of water. We are just help the nation to save the precious potable water by reuse of the treated sewage for the various applications. So reducing also the burden of the land acquisitions by saving of the precious lands. Just few photographs. Is our one of the largest plant in Indore, 245 million liter per day. In Nagpur, we have a 200 million liter per day. Aurangabad, and this is a completely odorless and adjoining very live, there is a human community over it. You can see is our home ground Ahmedabad Municipal Corporation recently set up the 155 million liter per day with the gas generation. Here is our 6 basins. These are our technology grounds. It's called as this basin 1, 2, 3, 4 like this way. And I will also show you the video how it's animation film also. So that concept will be clear in your mind. So basically this is a gas generation plant. So primary clarifier over here. This is a gas chamber. This is admin building, and this is a gas here. This is a gas chamber. So they will produce. Now recently we commissioned. So gas installation, the gas generation units are under installation. treating water already they have started. I appreciated the efforts put by all over us, including the corporations and contracting fellows. So we have discussed a lot of things. Now, this film is very important. You can see the animations, and so that the concept will be the clear what happened when the water comes and what happened to that water and how it goes out. Can you hear voice?
No, sir, voice is not audible.
Hello?
Sir, voice is
Not
not.
there.
Yes.
Okay. Okay. Now you can hear?
CTEC is a cyclic activated sludge technology. CTEC is promoted globally by a Navi Mumbai-based company, SFC Environmental Technologies Private Limited. With offices and representatives located all over the world, SFC has built many sewage treatment plants around the globe. In India, many municipal corporations have installed CTEC-based sewage treatment plants with capacities ranging from 0.45 MLD to 137 MLD. CTEC generates In addition, it saves 50% energy, 50% land, and more than 50% in O&M costs, thus making its life cycle costs minimum compared to other technologies. CTEC is completely automatic with stainless steel decanters and very efficient and specially made fine bubble diffusers. These plants are made aesthetically appealing with good landscaping to attract people to visit and understand the importance of sewage treatment. The raw sewage first enters into wet well through core screens. These screens remove large floating objects which otherwise clog the pumps. Submersible pumps in wet well pump sewage to stilling chamber. In stilling chamber, velocity of flow is reduced, and then sewage flows gently through the fine screens with 6 mm opening to remove fine floating matter. And other heavy inorganic particles are separated and removed. Thereafter, sewage is sent to CTEC basins for further treatment. In the beginning of CTEC basin, selector zone is located. Conditions favorable to good flock forming bacteria are created in selector zone, which helps in removal of nitrogen and phosphorus in later stage. Sewage from selector flows through baffles and then into main CTEC basin. Diffusers specially made for the process are fixed at the bottom of the basin to provide oxygen required for the bacteria. The process of carbon oxidation, nitrification, denitrification and pee removal takes place simultaneously in the same tank. It is simply and reliably monitored by online control of respiration rate. Clear supernatant from the top is drawn out via special stainless steel decanters. Chlorine is added to treated water to remove pathogens. At the end of the process, clean water with BOD less than 5 ppm, suspended solids less than 10 ppm, total nitrogen less than 10 ppm, ammonia less than 1 ppm, and phosphorus less than 1 ppm is generated. Biological sludge generated during the process is dewatered using centrifuge and used as manure. Entire CTEC SBR process is run automatically through PLC and SCADA. Treated sewage from CTEC can be used for industrial use, gardening, toilet flushing, construction, washing, etc., thereby saving valuable drinking water reserves.
So hope you enjoyed this thing. Hello.
Yes, sir.
Yeah, hope you this thing without any interruption.
Yes, sir.
Yes, sir. Yes.
So after this thing, we have just talked about the liquid waste. So our achieving remarkable achievement in this field. So we have told we have been told by the department, now what you can do for the solid waste. Everybody know when in Ahmedabad, if we talk about the solid waste, everybody have some picture at the Pirana. There is a huge mountain of the solid waste. So department asked us, what you do? Well, you can you do something for that? So for that we have our engineers and all, they have visited all the many countries and just they have observed what they are doing and what is doing and what we can adopt and like this way, because there is no setup, we can say that there is no kind of the manual over here earlier. Later on stage, the department or government have prepared some rules, guidelines. So in the 2016, so we can say it's the municipal solid waste guidelines 2016. So excellence, their norms. For example, in the norms, they have asked that we cannot burn the solid waste directly because they produce some lead and some other very hazardous gases in the air. So just we start our presentation, next presentation on the solid waste. What we have done, it's a very, I think I would, I'm sure that you will also like. As I told that we have visited many things, and after that our all observations, we have concluded that in India there is a no segregation at the sources possible. I think up to the 10 years, 15 years not possible, because every waste there comes a mixed waste, solid and wet and everything. Some people are following the rules, some are not. But at the doorstep, at the treatment plant, they combine. Maybe sometime they segregated, but our main point is that we have to fight. We have to establish the process with the mixed waste. So we have first established the 100 ton per day municipal solid waste treatment plant at North Goa at the Kalangut near, which is fully compliant in India's first plant who followed the SWM 2016 rules and totally integrated plants. Till date is the talk of the, we can say it's the talk of the town. See, we all agree that groundwater contaminations happens if garbage destroyed us. Very poor sanitation conditions, slum around, air quality degrading day by day, breathing problems and poor health. See, near Pirana, I think up to the 5 to 10 kilometers area, there is some air conditioning also the problems because of some hazardous gases the producing. So it's nowadays it's a huge one of the critical conditions. So how we solve the garbage problems? So as I told you earlier, government have those put the legal provisions under the SWM 2016 rules. What the rule says, there is a lot of other things. Just for our few of, I'm giving you the few of idea. Okay, what the rule says that. So this is a mandatory to segregate the mixed waste into biological, degradable, and non-degradable the fractions. Biodegradable fraction to be treated via biomethane and compositing method. There is a second point is incineration of only non-recyclable RDF having a calorific value more than 1,500 kilocalorie per kg or more. And this high calorific value waste to be supplied for the co-producer power plant and the cement plants, because they have to compulsory to take this thing from the corporation, but subject to it should be the more than 1,500 kilocalorie per kg. See, the emission of the standard include these carcinogenics, compounds, dioxins, furans, and heavy metals in the mandatory online samplings. Fly ash, acid, and bottom ash to be sampled and disposed in the hazardous waste handling facility. Other measures include this odor control, effluent treatment, proper enclosed shades. It should be the proper enclosed shades, health and hygiene of the safeguards. So just we think that why these provisions are relevant. So typical characteristic, just we go through the typical characteristic of the Indian municipal solid waste. We can see that 40 to 60% is a bio-waste or organic, 5 to 10% is recyclable, 20 to 30% inorganic or non-recyclable, 15 to 30% inerts like sand and stones, 50 to 80% moisture, and calorific value is a 600 to 800 kilocalorie per kg. See, we have very poor, this is a fact, is a mixed weight characteristic. And in the dry, we can say the wood, chipboards and rubbers, textile, glass percentage, metals and miscellaneous, and bio waste is a 60% of this is a wet portion. So waste is mixed in nature with high organics and high moisture and very low calorific value. These are the characteristic of we have visited abroad, and our engineers visited abroad and many countries, and also in India. So it's a unique threats in India. This is a mixed waste. So that's why they emphasize the new rules that to recover the recyclables, segregate mixed waste into biodegradable and non-biodegradable fraction, biomethanization and compositing for the biodegradable fraction, incinerate only RDF, the calorific value more than 1 kilocalorie per kg, then and then we can incinerate. Send this RDF to, if they have a more than 1.5 this kilocalorie per kg, to power plant and the cement plant and for the processing units. Install online monitoring lab equipment to measure the synergics and other in hazardous landfill sites. Just fact and files of the India's first this integrated 100 TPD solid waste plant at Goa. These are 100 ton per day. Total area we occupied is a 5.5 hectare. Capital our investment is 150 crores for 10 years. We are paying back to 30 crore per year for 10 years. See, this model is, we can say, there is a various kind of the modality in the government departments. First of all, that's called a EPC, EPC contract. They are just one the project have their budget, capital budget as well as O&M, and the bidder has to bid, and who is the L1, they will get the job. And will be provided by the government. That's called a EPC modality. This kind of job, because government don't have huge money, so they have changed the modality, not change, but we have also have some other modality. We can say it's an annuity model. Annuity model, in short, that I have to do some work and government pay me accordingly, whatever the fixed rate. Okay. So this called as an annuity. So government need not to invest at this time huge money of 150 crore, but they repay per month O&M cost and the capital cost as per the interest. So capital investment cost is 150 crores at that time, 10 years. At nowadays, we bring it down because this time we introduce the most of machinery imported. Kilowatt per day, and the rest of that we are giving back to the state grid, and the state electricity board also give us the money for RS5 per unit. Old remediations, that is a 55,000 tons removed up to the 6 months at the rate of this thing. See here, if anybody from us visited near Pirana sites, we are seeing that a lot of people are saying that okay, that mountain bring down and fantastic work going on. Okay, nothing is better than something they are doing. But this call say is a not a new treatment. It's an old remediation, we can say. They are just removing that old type of the mountain of the garbage through this vibratory screens and all these things. But nothing is better than something they are not doing. So here some brief layout of these our garbage plants in Goa. We can see here that Weybridge trucks incoming. I think some video is here, so we can understand that easily. But as a shortly, we can say these machines, this machine we can see is a trump card of all this process. Because as I told, how we segregate, mix and dry at source, no one can. So we introduced this Italian technology, this company, and also we have from the France. So this called as Orax machines. So they segregate this wet and this thing. We can say the segregate the mixed waste and dry waste and organic and unorganic. And accordingly, we have set up some lines to create, and some we are also getting some recyclable quality. Nothing from this plant, nothing we are going only below 10% of this thing. We are just inserting use for the insert, the landfilling. Okay, so for example, if the 100 TPD, so only the 10 tons, the remove only the land side. So only 10 tons. There is a grits, concurs like this way. All rest of all this thing is recyclable. Here some photographs. You can see that how earlier it seems. There's existing dumps, waste, there's remediated and cleared, land recovered, RDF sent to the ACCWD, and that compost used in the house. And we established these new plants. Here is this admin building over here, and these are the plants. There's a remediation, that is a multi-dash vibratory screen. Many of us, they have seen this in our Pirana site. This is called as a multi-deck vibratory screen to remove the old one. From what we get from this old one, that is a compost. This is a 25 to 30%. This is high quality of the compost for use as a fertilizer in agriculture. 50 to 60% is RDF. We having a high calorific material, plastic, papers and clothes, alternative fluid, cement, etc. to produce the additional electricity. Because the idea of the cement factories and power, they must have to buy from the AMC, the calorific values at certain level. Reduce the residuals and the landfill, 10 to 15% to the landfill. So not like that every garbage we have just dumped. So if there is volumetric is a lot of lands. See, recycling materials 5 to 10%, compost 15 to 20%, electricity, that generation we have the 7 megawatt, and RDF there 20%. And reduce the residuals to landfill. This is our new one for that. The trucks coming and the weighbridge is there. Motorized rolling shutters, self-supporting roofs, all as per the we have aesthetically as well as the following the rules that ultimately we have to provide the huge air ventilations inside. So input feed bunkers, chain belt conveyors, all the, you can see these are tap area, all the solid mixed waste will come truck over here and they emptied in this belt. These automatic bag opener machines, the crush, segregate roller screens over here for sorting stations. More than 15 fractions. Here we have just put us, this portion is only some manual because we have to give some job also to the local people or just hand fractions over there. They have to just stand up. All this work will be continued. They have to just pick up what they have dedicated for that. It's so easy. You can see a lot of fractions, plastic bottles, glass bottles, and like this is a 15 section over there. This is a baler press. So we just packed due to the container storage. Now this is, as I told you, that 100% of the mixed waste is segregated into wet and dry fraction by Orex technology. This is we introduced in India in the big way because this machinery, completely technology from abroad, and as per this, because Indian mixed waste is a very, in India, everything, it should be the robust, long lasting, because if we fully adopt the foreign technology blindly, so maybe we fail or because they are very sophisticated. So we have changed as per our engineers' inputs. So that segregated pure organic fraction that comes from this Orex is here. What happened? The mixed waste they are pressing. I am giving some animated film, just small portion how it works. That you can see that. See, it's just like our lemon crushing machine over here. Again, I'm just giving you. Pressing. So, same kind of this machine work here. So this is a crushed material. This we can say it's a organic, pure organic fractions. So they are going in from the fermenter, and that's segregated through the RDF line. This call as a, we can say it's a unorganic. Most important step, segregation. As I told you, it's a key aspects of this municipal waste. Only then downstream treatment process works. If we cannot adopt this, our all the process will be the fail. As you see in this thing. So as we discussed that Orex separate the waste into two fractions, wet organic and dry inorganic. That organic or wet portion go for the fermentation and from the biomethanization and the compost. Through this biomethanization, we can produce the electricity, and compost we can use as a manure. And whatever the organics, sorry, inorganic or dry. After this removal, this thing from the heavy metals and magnetic separate magnet, we also provide to remove the some conditions of the through these metals and many other things, so that after specific treatment we can use this RDF, we can use the thermal process and crow processing units. As we said that 90% of the pure wet fraction from Orex go to the biomethanation and organic fraction, dry type fermented, and composite in vessel composite drums. Is biogas holder. This is a gas engine. This is in vessel composite drums, compost screens. Here is screw press for the dewatering of the sludge. Now dry fraction from this Orex goes to the RDF line. As I told you, the magnetic separator over here, flip flow screen, wine shifter, and separated the inert fractions. We can see this, it's a pure inerts. This ultimately it should be less than the 10% of the total capacity of the plant. In manual, there is a 10%, we are achieving less than 10. What means that all the recyclables and all, nothing goes out from this plant. It's a fully automated PLC SCADA room and monitoring all the activities. Under these sets, how we set up our all this thing, we can see. You can see the RDF lines and this screen over there. There is extrusion press, the Orex machine over here. Now, again, the liquid waste is again, then what we do? So raw effluent from all the plants, the raw effluent after the screw press and all these things, the washing drains, then after screening comes into equalization tank. Then we put the membrane bioreactor system over there. That clear water comes to the reverse osmosis RO. And for that, after this water, we are using this flushing, gardening, and same compounds. That is our effluent treatment plant sets. Because in the manual, the government, the manual asks that this kind of the facility, every garbage plant must have. You can see the huge ventilation fans to keep oxygen proper and keep environment healthy inside the sets. As I said that sanitary landfill sells only for 10% of the residuals, inert fractions. See is a bentonite ceiling. HDP, this seat is over there. So on that, the dumping. So as we have seen and discussed that Indian garbage does not have the wealth or gold as commonly thought. See, a lot of time because even today, government is asking the tender that on PPP, public-private modality. So what they see is they have a wealth. Okay, wealth is that, but it's not like that way. Okay, you can sell and earn money lots, and you can put that money also to set the plants. Nothing like this way. It has some value, as I said, which can offset part of the plant of the operating cost. And first of all, we have to treat this thing not to generate the revenue. That concept, because even today, so many department is still thriving whether they have to go with the EPC annuity or this kind of the modality on the PPP base. But PPP model is absolutely failed over here, unless and until in the bridges and roads and some other entertainment segment, the PPP model, they failed. Because if somebody, even the contractor, why they invest the money to earn something, na? But if they are not earning too much, then how they can, the project will not viable for him. And finally, the total project goes in the box. So that should be there. We have to change also the modality of the inviting the bids to allot this kind of the project. Now, selecting the proper treatment technology is very critical. So we have to consider the Indian mixed waste that have a high moisture and having a low calorific value, and environmental impact of disposal of these carcinogenic and hazardous residual, then long-term impact on future generations. So all these aspects that we have to consider, and accordingly we have to fix up the technologies, and we have to fix up the setup, and we have to incorporate in the inviting the bids. Capital and operating investment are required to be made by the government to ensure the success in these segments. Why I am this talking? Because in earlier we have discussed about the liquid waste. I have shown you a lot of sewage treatment plant on SBI and this thing. But after 10 years ago, the same situations, because a lot of the corporations, and they are expecting that somebody will come, invest on, and then they operate. But not every time and every project this modality will work. It depends. But in water segment, wastewater segments, solid waste segments, absolutely that modality failuring, and it will be failed. So nowadays, many of the departments are now asking the bids. They are changing the modalities by slowly. Particularly the solid waste, they have started. So I'm very thank you to all of you for listening me for on this topic, and also I'm again thankful to all of you for inviting me on given me the opportunity to present our few remarkable success. So before to conclude the sessions, again, let's we start the India's first solid waste plant at Goa. This video excellently we have prepared excellently. I think it will clear all the concepts of what we have done and what is going on these plants. And I am also inviting all of you, sir, under the guidance of your principal, sir, you visit our Goa plants whenever you convenient, because a lot of agencies, your Gujarat Chamber of Commerce and engineers associations and many people they have visited. So it's what to see. Let me just start the video.
Goa, the pearl of the East and India's most preferred holiday destination, is blessed with abundant natural beauty that draws thousands of visitors to this tiny state every single day. But beyond the beauty, glamour and excitement lies a deadly menace: garbage that threatens to destroy Goa forever. Governments had been struggling to find a solution to manage Goa's municipal solid waste in a scientific way. Fortunately for Goa, the then Chief Minister, Mr. Manohar Parrikar, took it upon himself to find a solution committee visited many waste treatment facilities both in India and abroad to study the technologies available for managing MSW.
This is a technology which is proven, which is functioning. That is important. There are technologies which are mostly theoretical and not suitable to our conditions. I feel this is one technology which is suitable because mixed waste is collected and treated.
This is what Goa required long back. Finally, we have come to it. And it is the right time that we set it up now, or it will be too late.
After careful scrutiny, the government of Goa awarded the work to Hindustan Waste Treatment and SPV formed by SFC Environmental Technologies Private Limited. And the work commenced under the supervision of an expert committee chaired by Padma Shri Dr. Kale, with members from NIRI, IIT Mumbai and BITS Goa. The land identified for this project that needed to be remediated before the construction and operations could begin. The team at SFC set themselves a target of not just building a waste treatment plant, but of defining the solution to manage India's municipal solid waste. Even while the new plant was being constructed, the adjacent mound of waste was taken up for remediation. 2 multi-deck vibratory screens were pressed into service along with a battery of heavy machinery and carriage vehicles that worked around the clock, and within a record 45 days, 50,000 tons of the old dumped waste was screened and separated into refuse-derived fuel or RDF and compost. RDF was sent to a cement company and the compost was used for green belt development. The complete old dump was cleared so that the new sanitary landfill cells could be constructed on the same land. While the remediation was in progress, construction of the new facility and erection of machinery continued at a rapid pace. Each process was being closely monitored by a team of experienced engineers to ensure the highest levels of quality were achieved. The installation of machinery was also supervised by trained technicians that flew in from equipment manufacturers in Italy, Germany, and other countries. After 15 months of hard work, India's first integrated solid waste treatment plant, fully compliant with SWM 2016 rules, was finally ready for operations.
Okay.
The waste is brought into the plant by panchayats in trucks and is weighed before being unloaded on the tipping floor. The front loader then takes this waste to the chain conveyor, which carries it into a bag opener. The bags are automatically opened and the contents are carried by a conveyor to the mechanical roller screen, where large-sized recyclables are screened and transferred on the sorting line, and the waste is sorted into multiple recyclable fractions. These fractions are baled and stored separately in proper containers before being sent to recyclers. The underfraction of the roller screen is taken to the Orex, which is an organic extruder press. This unit automatically segregates the mixed waste into dry or inorganic fractions and wet or organic fraction. The organics are extruded out of the mixed waste under very high pressure in a pulp form. More than 95% of the organics, along with moisture, comes out into the pulp from the mixed waste. The pulp is then pumped into the dry thermophilic fermenter, from where methane from the biogas by chemical scrubbing process, and the pure biogas is fed to 2 engines with the potential to generate 7 megawatt hours per day. The excess biogas is flared off. The digested sludge from the digester is then taken to a screw press where it is dewatered and the fibers are fed into an in-vessel composter that converts it into compost. The dry remainder from the oryx is further taken via a permanent magnet to remove ferrous metal, followed by flip flow screen and a wind sifter for separating the grit and the RDF. The RDF is being used for co-processing by cement companies, and the grit is used for filling up low-lying areas or disposed into the scientific landfill. All effluents from the plant, including flushing, flow washing and sewage, are taken to an equalization tank. Suspended solids are settled in the Clary flocculator. pH is corrected and the effluent is then taken Once the organics have been removed, the effluent is pumped into a reverse osmosis unit for removal of dissolved solids. The clean and treated permeate is then used for gardening, floor cleaning, toilet flushing, and other non-potable functions. All that remains at the end of the process is the grit, which is less than 10% of the waste received. This is put into a scientific landfill that is built and lined with bentonite, HDPE, and geotextile covers. At Hindustan Waste Treatment, safety is of paramount importance. The complete plant can be monitored and operated from a central control room via PLC SCADA-based systems. The engineer on watch also has got a complete visual contact with key areas of the plant through a series of cameras. We are also equipped with all necessary safety features that includes a full-fledged firefighting system and an emergency quick response vehicle. Key personnel are trained in the use of the safety equipment. The odor levels are kept under control by effective use of large volume ventilation fans that draw the air from the process area and pass it through a biofilter before it is vented to the atmosphere. The ambient air inside the sorting station is always kept clean and cool by using air filter and cooling systems. At HWT, we ensure that health and hygiene of our employees is given top priority, and special efforts have been made to integrate these features into the design. Already see a noticeable change in the surrounding natural environment. At Hindustan Waste Treatment, it is our aim to transform India into a true Swachh Bharat.
Hope you enjoyed this video.
Yes, sir.
I hope you enjoyed this video, no?
Yes, sir. It was really very nice.
Okay. Because this topic is too critical, and because many of us, time is a very constraint. So some slide I moved fast, but if any queries and anything, you can directly contact us. And you all are most welcome to visit in Ahmedabad, our largest plant of the Gujarat, 155 million liter per day at Pirana. Any of your convenient time. So, and solid waste, the most delightful location at Goa. So all are the welcome for that.
Ajay bhai, we have, by the time your lecture was going on, we have received some requests from our faculty also that they would surely like to visit your plant in Kirana at least because it's in Ahmedabad. So
Very
we
nice.
will be in contact with you with probable dates which would be convenient to you so that it can be arranged. Right, sir?
Yeah. You're most welcome, sir.
Thank you for your generosity.
Yeah. No, it's actually it's this kind of the plan for the future generations. So okay, these students, they are our future, maybe the think tanks, and so definitely it's also worth to see that.
Radhika madam, we can conclude. You can give the vote of thanks.
Yes, sir. Sir, before that, we would like to present you a certificate of appreciation. So we will share it on the screen. Praful sir, you can give it virtually.
All right, on behalf of LM College of Pharmacy, Institution Innovation Council, AIC, LNCP Foundation, and SSIP, we heartily appreciate the time spared by you for interacting and sharing so much of technology which goes into managing each and every waste which goes out of our house every day. It was really interesting to understand all the processes which take place after they leave our house and what happens at the end. So I really thank Mr. Ajay Gajar for sparing this time and giving a wonderful presentation.
Thank you.
Please accept the certificate on the behalf of the college and the principal and the faculty and the students. Thank you very much, and we hope we keep the deliberations of technicalities going on with some other interesting topics also related to pollution. Thank you very much, Ajay bhai.
Yeah. Thank you to all, sir. Thank you.
Thank you, sir. I would like to request Dr. Radhika Pandya ma'am to present a vote of thanks. It's over to you, ma'am.
Yeah. Thank you, Falguni. So, welcome, sir. I'm really glad that today I have to propose vote of thanks on this occasion of National Pollution Control Day celebration. And I also would like to acknowledge that all the seminars we are organizing this year is as a part of a Diamond Jubilee celebration of being into existence. So our college has actually completed 75 years of foundation. So this whole during the whole year, we are going to organize various seminars as a part of it. I would really like to extend my heartfelt gratitude to you, sir, for sparing your valuable time and delivering a talk on a topic of such a national importance. The session was really very nice and interesting. The CTEC technology, which is developed by your company, is really a breakthrough technology, I can say, where the sewage treatment plant are odor-free, eco-friendly, visit-friendly, and also through it, you have very well showed that how we can treat the wastewater and make use of it for various other purposes except consumption, and hence save plenty of drinking water. By this CTEC technology, the requirement of land has also been reduced. So in less space, we can actually have a good sewage plant, and along with it, we can have a reduced power consumption also. And really, it's a fantastic technology where the sewage treatment plants are actually used for the revenue generation. So we would like to congratulate your company for developing such innovative ideas, which are helpful in controlling all kinds of pollution in the world. Also, we are delighted to know about how your company have taken initiatives for the solid waste management, incorporating the OREX technology. So really, sir, we all are very glad to listen from you today. Thank you very much. And I would also like to express my gratitude to our principal, sir, Mahesh Chabaria, sir, Praful, sir, President of IIC LMCP, Srinivas Savle, sir, for supporting us with this activity and always providing us encouragement and motivations. And I am also grateful to Vivek Chawda for handling the Zoom platform and managing the program. I also thanks Vidisha, Falguni, our host, and all the remaining student volunteers for a very well arrangement, management, and execution of program. And as no program can become successful with audience, I would like to extend my big thanks to all the participants, especially the students. I hope they have got a very good, well take-home message from your talk. So thank you all very much for making this seminar a success. Thank you, sir.
Yeah, thank you. Thank you very much.
So, sir, now we shall end the meet.
Yes, sir. Yeah.
Okay, thank you.
Okay. Yeah.
Thank you, everybody, and have a good day.
Yes.